Well, did you use one of the packages or you wrote everything yourself?
No, yeah, I from the PDF, the PowerPoint you sent, I
Uh-huh.
went to that repo.
Okay, so you use the Python code, or
Yeah, the
you
Python code.
the Python code. Well, we have to debug it uh, 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 using simple examples. So I'm not really sure. If you send it to me, I could try playing with it and see what's going on.
Okay, okay, thank you.
Yeah. Uh, uh, yeah, it's hard to say without really looking at some of the examples. But it does run. It's just that it's not inserting properly. Or what was your reading?
Yeah, it does run, but the problem is that the root node, it wasn't the full range. It wasn't from 1 to 15. It was something like 1 to 3.
Uh-huh. Yeah, so that may be because you because every time it rotates, it's going to change the route, and
Hmm.
so you have to go and fix the rotation code as well in order to make sure that it has the right range.
Okay. So the
If you
issue
did
could be the
not,
rotation.
yeah, if you did not fix the rotation code, then it's not going to work right.
Okay, thank you.
Okay, and we can debug that, because clearly the rest of the insertion is working out right. The key is there. The keys are in the right order. It's just these ranges that are not being set right. Is that what you're saying?
Yeah, exactly. It has both keys,
Yeah.
the range, and then the second
Okay.
key is the
Got
number
it.
and the frequency.
Okay. Yeah. So when you rotate, the ranges change. And let's see if I have an example here to show you. So let's say, yeah, let's take this example. Can you see this?
Yeah, I can see your whole screen right now.
Yeah. So give me a second. Let this come up on my screen as well. Um, Come on. Yeah, there you go. All right. So here is the red black tree. Oops. Here's a red black tree. Now, if I were to do a right rotate at 52, what would happen? Uh, 20 would go up and 52 would come down, right? So 20 would become the parent of 52, and in fact, nothing else would change. Uh, so this guy would go up and this guy would go down, right? You clear about this?
Yeah.
Uh, and uh, uh, the problem then is that the ranges will change. Here, the range for 20 was 16 through 20, whereas once it moves up, the range there is going to be 16 through 55 because it's the root of that subtree, right? So the range needs to be changed when you do the rotation.
Okay. Okay, perfect.
Yeah. So yeah, we can talk more separately and see how to fix that.
Okay, thank you.
Other questions?
Yes. I know the red black tree in Java's like
Yeah.
tree map and tree set.
Yeah.
In Python, is there an equivalent?
Uh, no, there isn't. It's not a data structure, but the link I sent you implements it from scratch, as far as I could tell.
Okay, okay.
Yeah.
And for the competition, we're not allowed to like reference outside sources, correct?
That's correct, um, uh, but you can print out whatever you want. Well, actually, for this competition, I don't know how the system is going to be set up. Maybe you guys know based on last Saturday's practice session. Did they tell you how it's going to be run? Are you going to have internet access or not?
Yeah, so they said we have access to everything as long as it's free and everyone can get to it. So if it's a service that you need to pay for, you cannot use it. But if you need to search something up online and it's
Yeah,
absolutely free, then you could
yeah.
use it.
So you could cut and paste code from somewhere else.
Yeah, from what I understand, yes.
Uh-huh. Uh, yeah. So I don't know that as well. John. Um, what we How do we fix that? So in the past, when we had face-to-face competitions, what we would do is to print out a set of programs that we think might be useful, and we would take it to the competition, and that we were allowed to do. The rules have changed this year because it's all virtual, and not only that, we're not all sitting in one room where uh, uh, previously all the competitors would come to a room and we would disconnect their connections to the internet. Here they can't come and do that in your house. So I'm not really sure they can stop anything. Uh, so my guess is that you are allowed to use code from anywhere as long as Lazaro said, it's not some behind some paid wall, right?
Right.
So in that case, keep in hand all these links for where you might be able to find appropriate code, download it, and you're free to run this.
Okay.
So for instance, the Python code for the RB tree that I gave you should be accessible even during the competition, which is again these are very unusual rules and very unusual times. So we're just adapting to something like that. Okay,
Makes sense.
and so you just download that and modify it as you wish.
Okay.
If it works, you're lucky, things are great. If it doesn't work, it's still your fault because you didn't download the right code or something like that, right?
Right.
Other questions? Yeah, but in answer to your original question, John, Python does not seem to have built-in standardized code for red black trees.
Okay. Thank you.
Other questions? Okay. Um, so I am going to show you a couple more things. But before that, I wanted to go over a couple of things. Let's see. Right. So you already know this. Well, these slides are actually incorrect. It wasn't. Yeah. The actual contest is on March 6th. It starts at 2 p.m. But make sure you're online by 1 o'clock so that uh, they give you enough time to understand the rules, understand the environment, understand other constraints, and there'll be some speeches for the opening ceremonies that'll give you specific instructions. Make sure you're there. Okay. The other thing that's important is the Discord uh, uh, connections. Have all of you guys taken care of your Discord account? And have you communicated this to ICPC? How many of you have not? Could I have could I have you show your video and have a show of hands, please?
Everyone here,
I think we're all good.
yeah, everyone here is part of the Discord server, and they've
Okay.
all added the organizers.
So you got some message from the organizers already?
Yes.
Okay. Um, for those of you who are not here, you may want to make sure, Lazaro, that they do have a Discord account set up, and they've sent this Discord handle to whoever is the ICPC organizers.
Yeah. Okay.
Okay. All right. Uh, then the next thing to know, of course, is that during the competition, your coordination is going to be key. So it's important that you guys work together as a team, which means that if there are 10 problems, it's a good idea to make sure that you divide these problems amongst yourself, and you attack these problems. And in the first 10 or 15 minutes, really your job should be to figure out the easiest problems that are there, and the ones that you think you have the skills to solve. And make sure you communicate it with the others and say, hey, I am going to be taking on problem number 6 and number 8, and make sure that no one else is also wasting time on the same problem. Okay. Uh, then my suggestion is that your goal should be to solve one problem in the first whatever time, say 1 hour. Uh, if each of you is able to solve one problem, I think you would have a competitive performance there at the conference, at the competition. So that's what should be your first goal. Once you solve one, then then you're ready to leap into some competitive mode, and you should attack whatever problems you think are within your reach. Uh, Trying to figure out the easiest problems and the ones that are within your reach is not that easy as it sounds. Uh, that's why it's a good idea to divide things beforehand and say, since you're 3 people, if there are 15 problems, make sure that the first 5 goes to one of you, and you say, okay, right away before the competition starts, talk to each other and say, I'm going to take the first 1/3. Uh, uh, so your other teammate will take the second 1/3, and the third teammate would take the last 1/3. Decide on that beforehand, so that you don't waste time coordinating on, okay, I'm going to take on 1 through 5 and you take 6 through 9, and so on and so forth. Just say your division is going to be 1/3, 1/3, 1/3, and make that division, uh, 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 have that discussion before the meeting. After that, spend your first 10 minutes looking at your 1/3 of the problems and deciding if any of these problems look like they are something you can solve. Not only you can solve, but you can solve quickly. So there are 2 kinds of problems. There are problems that you can solve for sure, because most of the instructions are very clear. And then there are problems that are very, very simple, and there almost always are 1 or 2 of those kinds. So look for those problems that are super simple, that require probably 10 lines of code somewhere, and that's it. If you can identify that among your 1/3 of the problems, and if you think you're qualified to take it on, go ahead and say, I'm on number 4. Okay, tell the others that's what you're doing, and start to work on it. When you're ready, when it's all debugged and it's working, then you tell the others that I'm going to be submitting this problem, and you go and submit the solution. Um, so make sure that there is decent, reasonable coordination for this. Okay. Uh, and after you're done, after you've submitted your solution, you got to wait for some time before you know whether the solution has been accepted or not. But in the meanwhile, you're going to be starting another problem, and you may want to again coordinate with your teammates and say, hey, I'm going to be starting problem number 3 now, so that others know as well. Now, it's entirely possible that all the 5 problems in your set, or whatever, all your 1/3 of the problems are just too hard, and you're not going to be able to handle any of these. In that case, you should tell your teammates that, hey, I'm done looking at these. I don't think I'm going to be able to solve any of these. Uh, uh, why don't I start to look at one of the problems from your 1/3? Okay, so try at that point you're going to need more coordination, and you can figure out what it is that you want to work on. Okay. Uh, uh, we haven't really trained extensively, so at this point it's hard to give you good advice. But in general, you may want to have one person who's an expert on these red black trees, one person who's an expert on graph problems, things like minimum spanning trees, shortest path, etc., etc. You you might have one of your teammates who's an expert on geometric problems, points, lines, planes, intersections, etc., etc. There might be another teammate who's an expert on number theory problems or combinatorial problems, uh, or or brute force search problems, or something that looks like just plain math. Uh, One of you may have better expertise than the others. If that happens and it shows up in your set of problems, you may want to point that out to your teammate and say, "Hey, look, this looks like something up your alley. Why don't you take a look at this and see if you want to attack it first?" Okay. And again, uh, in any team, some of you are likely to be faster than others in terms of typing, in terms of debugging, in terms of getting things to work. So if you identify an easy problem, it's a good idea to get the fastest teammate to work on it. So feel free to hand it off and say, uh, John, I think you should do number 3 first because this looks like something you could do very quickly. Things of that sort. So coordinate. Remember, if you solve a problem, you get essentially you get 1 point. But if you solve the problem faster, that's worth a lot more. Okay. Uh, there are going to be some really crackshot programmers there who will probably solve the first problem in less than 5 minutes, and it's mind-boggling the speed at which some of these people work. Don't be faced by it. Such is life. You guys are will get there hopefully next year. Okay. For now, we're going there for the experience of it. But if you're able to compete and really do well, I would say hats off to you. That would be amazing. Um, so this it requires a kind of mindset and it requires a kind of attitude to go and approach this competition. You have any more questions?
Yes. I'm assuming since you said any language is acceptable, runtime isn't part of the judging criteria.
Oh no, it is. Oh, it is. Um, uh, Typically, it's 3 seconds, but they will tell you on the problem itself what the time limit is. If they
Uh,
don't say anything, it's either 1 minute or 3 minutes. Depends on some of these problems. Uh,
Okay.
I will check up the rules. If I learn anything different, I will let you know.
Okay.
So yeah, your point is that hey, Python programs are going to be slow and C++ is going to be faster. So if they're allowing Python, what does that mean? Well, they've taken that into account when they give you the problem sizes, somewhat. Uh, so I would say uh, uh, using efficient algorithms and using efficient data structures is still very, very important. uh, where you could use red-black trees to speed things up. If you don't use it, very likely you won't hit the time. You may go over the time limit. Your solution might not get accepted. Uh, an n squared algorithm versus an n log n algorithm. If you don't use red-black trees, maybe your algorithm runs in n squared time. If you use red-black trees, maybe it runs in n log n time. They are smart. What they would do is they would use n to be something like say 100,000. If they use n to be 100,000, n squared becomes 10 to the power 10. That's 10 billion operations. And typically 10 billion operations, it doesn't matter whether you use Java or C++, it may not make it in a matter of a minute. Uh, uh, so uh, so so they will set things up in such a way that language may not make a difference if you don't use the right if you don't use an efficient data structure or an efficient algorithm. Okay. Other questions? All right. if there are no other questions, then let's move forward. Um, Right. So we've been talking about red-black trees, but just to make sure that everyone is on the same page. I mean, I could start a new topic, but I decided that it was not worth it. We are sticking to somewhat simple problems for now. That's fine. I think we're going to train for next year, and all of this is think of this as preparation for next year. Is my point. Uh, so we've talked quite a bit about red-black trees. So let's think about new questions that we can solve using these red-black trees. So let me quickly recap what we did earlier. Um, Give me just a second. All right. We know that in general, these red-black trees are perfect for dynamic data, for storing a dynamic set of values. Um, so any set of values where things are being inserted, deleted, and searched for. So as long as you want to do search, insert, and delete operations, red-black trees are absolutely fabulous. So so let's start with a somewhat of a simple problem. Let's say that I have a set of students, and I've been given their ID numbers, and the students either live in Broward County or Dade County. So let's say each student uh, is has an address that's either Broward County or Dade County. And let's assume, just for the sake of argument, that other counties are not there in this class. So now let's say I want to answer some questions. Now, if we know that because it says dynamic set, what that means is that new students might get inserted, or students might get deleted from the set at any given time. And we want to maintain this information so that we can answer interesting and useful queries. So what if I had a query that says, find, uh, so it's not if, find the number of students. So let's say I give you two ID numbers, and I say, uh, find all the students between these two ID numbers and tell me if this number is even or odd. Um, I don't know if this makes sense. So let me ask you one more time. So in general, let's say we want to count the number of students between two given ID numbers A and B, and to make it easier, I'm just asking the question: is this number even or odd? Okay. Now, uh, of course, if you if the data set is static, then I can just go and count for whatever range between A and B. I can just sort all the IDs and then start from A and go up to B, look through that entire set and check if the number is even or odd. Okay. Uh, Remember, I've also thrown in this confusion with the Broward County and the Dade County. So it's not enough just to know how many students are between these two ID numbers, but I also need to know how many of those are from Broward County and how many are those from Dade County, right? So there's an extra layer of complication here. Uh, so clearly, a red-black tree would become very valuable because uh, I can essentially store the student information in a red-black tree where the key value, the primary key, is their ID number. Because all my searches are based on ID numbers, therefore that's what I want to use as a key, right? Now, once I create a red-black tree and I store all the student information, I can do these searches. And if I augment that information with some appropriate stuff, then I could do more meaningful searches like how many students are between ID A and B. Or I could ask more interesting questions like how many students between A and B are from Broward County, or is this number even or odd? So these are all different kinds of questions that one could ask and that we can answer using the same data structure. That's what we're going to see. Okay. Now, how do we do this using our augmented red black trees? So back to what I was saying earlier. We're using a simple red black tree, and the primary key, of course, is the ID number. Now, in each node, we would like to store extra information. That's the augmented part. That's the augmented data structure. Now, the question is, what kind of information are we going to store that's extra in each node? Any suggestions?
Can it be within the range of those IDs? We can store the number from Broward and the number from data.
We don't have ranges. Um, uh, so yeah, so you're thinking of storing ranges now. So by the way, even though we used ranges in what we discussed last time, it's more useful for you to think of each node as just storing one value, but the range that it represents is everything that's in its subtree.
Mm-hmm.
Okay, so the range in some sense is not explicitly stored, it's somewhat implicitly stored.
Okay.
Okay. It's useful to think about it that way because then a lot of other things become easier. That would be my advice. Um, so yes. So then the question is, what is it that you would store in each node? So you would store the range of the subtree that it represents, right? Um, so every node has a range. That range corresponds to the range of values in its subtree, right?
Yeah. Yeah.
Uh, so that's fine. That's one. Is there anything else that we want to store?
We need to know if the students are from Broward or Dade counties.
Yeah.
So,
So we do want that, but for this particular question that you see on the screen, we
oh,
don't really need that, right?
true.
We're
Okay.
not quite. That's actually the next question, but yeah.
Okay.
Uh,
Okay.
but,
Okay.
but here I don't need that. So
True.
here all I need is a range, right? What else? Is there anything else I need?
If that range contains an even or odd amount of students.
Well, um, okay. So do you want to store just the even or odd information, or do you want to store something else?
Maybe an index so we can get like offsets.
Uh, Remember, we discussed this. Index is not a good idea. Why? When
Oh,
you
because since it's dynamic, it will change, right?
right,
Sorry.
every time you insert, indexes change. So you definitely don't want to store indexes. That's what we're moving away from, right? So instead, what are we going to store?
A number of students.
Number of students where?
Within the range of that node.
Within that subtree.
Yeah.
Okay?
Yeah.
So think in terms of subtrees.
Okay.
Subtrees represent range of values
Mm-hmm.
and number of nodes. Okay, so in each node, we're going to store at least two pieces of information. One is the number of nodes in the subtree. Remember, we used size. That's what we called as size in the examples we discussed last time. So size here is essentially the number of students, but also because that subtree represents a range, it's essentially the number of students in that range, right? So we could store the range, although uh, 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 yeah, sure. Actually, that would become useful, and that would make our calculations more. Uh, they will make them more convenient. So we store essentially the smallest value as well as the largest value, and that'll give us the range. So for each subtree, for each node, we will store the smallest value in the subtree, the largest value in the subtree, and the number of nodes in the tree, in the subtree.
But Professor, we can only do that if it's sorted, right?
Well, since we are storing it in with the primary key being the ID, and because we are using a red-black tree, it is in sorted order.
Okay, so we already assume it's sorted. Okay, okay.
Because it's a red-black tree, it's already a binary search tree. So it has to follow that sorted order. In the left subtree is always going to have smaller IDs. Right subtree is always going to have larger IDs. Right?
Okay.
Other questions? So is the picture clear to you now? So every node tells you what is the smallest value, what is the largest value, and how many nodes are there in that subtree. And smallest and largest gives you the range, and the number gives you the size. Clear?
Yes.
Okay. So now, given that information, can we now answer this for any query that we want? Meaning, can we answer whether the number of students between these two ID numbers is even or odd?
Yes.
So now this becomes quite easy because we will do exactly what we did last time, namely for any given range, we will start at the root of the tree. We'll decide whether it's all to the left or all to the right. If it's on both sides, we will do both. But then we'll start to figure out the how many students or how many nodes are in that range, and then in the end we will add them all up to get the right answer, right? So we'll ask exactly the same question we did last time, except that here it's going to be number of students in that range. Is that clear? Somewhat? So, so we know how to answer these questions for any given range by doing exactly what we did last time. So now let's try and modify the question a little bit. What if we wanted to know the number of students between these two ID numbers who are from Broward? Well, now we obviously have to add some more information to the nodes. So what would we add? What information would we add to each node?
Yeah, in this case, we need to know like if the students are from Broward or Dade counties. But I don't know how to do it.
But what are you going to store in each node?
Well, let me think about it.
We can probably store like a Boolean value, false for Broward, true for Dade.
Maybe
Okay.
another way we can also do is a tuple where the first number is how many students are from Broward, and then the second number is how many students are from Dade. And then if we combine them, we know how many total students in that subtree. But if we only get the first one, we know how many students are from Broward. Or if we only get the second one, we know how many students are from Dade only.
Good. So yeah. So by the way, every time you say that, you should say from the subtree. So for every node, we not only want to store the number of nodes in that subtree, but we want to know how many of these nodes correspond to students from Broward. Okay. Or we could store Broward and Dade, and of course, adding them up will give us the total number. If it doesn't add up to the total number, then we may want more pieces of information there. But for now, since it's only Broward and Dade, let's just assume that at every node, we'll store the number of nodes in the subtree from Broward and the number of nodes in the subtree from Dade. Okay. Now we have to, so once we do that, we can pretty much answer this question because we are only going to be interested in the Broward number, right? So again, we would do exactly what we did before, except that we are going to be counting the number of students from Broward. Is everyone clear about what I'm saying? Because otherwise, I could go through an example for you a little bit more. But if everyone's clear, I don't want to waste your time.
Can you go through an example?
Okay.
Yeah, please.
All right. So let's go through an example. I have to go back to. So I think here we had, yeah. So this is a picture where every node has the size information. This size, of course, is the total number of nodes in that subtree. So think of each of the numbers there. So for instance, this is ID number 16. Think of this as ID number 20, and so on and so forth. Okay, fine. So this tree already exists. All the students have been put into the red black tree, and I have size information. If I put size information like I've done over here, then I know that I can do the range question quite easily, uh, and I can figure out how many students are there between ID number 55 and 90. We know how to do this, right? That's what we discussed last time. So now we are we are uh, we're asking the question: is the number of students between 55 and 90, is it odd or even? That was the first question we asked. The second question was, what if some of these students are from Broward, some are Dade? We don't know which ones. So let's just say that all the well, let's say some of these are labeled as Broward, some of these are labeled as Dade, and we want to know how many Broward County students are between the IDs of 55 and 90. So let's just say that in each of the nodes here, I have another number. Okay, so along with the number 13, I have say the number 5 that says there are 5 students from Broward. Along with the number 4, I have the appropriate information from this subtree, and so on and so forth. So I have 2 pieces of information now at each node that tells me in the subtree how many students are from Broward. Uh, in fact, we could do an example here. Um, let's say that 16, 20, 52, and 90 are from Dade, and all the other odd numbers are from Broward. So Broward is 55, 65, 61, 71, 85, 81, 93, and 101. Let's assume that these are our Broward students. Fine. Um, so how many Broward students are there? What would you say is the right number I'm going to store here? So there are a total of 13 students. Yeah, I want to know how many Broward students there are. So that would be one, 2, 3, 4, 5, 6, 7, 8. Looks like 8 students from Broward. Fine. Uh, so I'm going to put the number 8 here up on top at the root, along with the 13. So 13 is the total number of students. Of these, 8 are Broward students. Clear? I'm going to do a similar thing at every node in the tree. So for instance, over here at this node called 52, what am I going to store? So there's only one odd number there, so it's only one student from Broward. Then when I come down to this 20, it's going to become 0 because there are no odd numbers. So in each node now, I have that second piece of information along with the size of the subtree. Is that clear? So that number tells me how many Broward County students there are. Now, if I want to do, let's say, the range 55 through 90, right? That's the example that we looked at. If I want to do 55 through 90, how do I now figure out how many Broward County students there are from between the range 55 and 70? So what would happen is that I would start at the root. I would know that it's on both sides. So I'm going to go to the left and count. I'm going to go to the right and count, and I'm going to count 1 for the root, which is a Broward County student, right? So that gives me, um, and then over here, I know that 55 is completely to the right, so I'm going to go down here and do the counting. And when I come here, I know that that entire subtree has only odd numbers. Sorry, that entire subtree is part of the range that I'm looking at, 55 through 90. So I'm just going to count that. So this one says 1, and this one student is from Broward. So far I have 1. I have 1 from the root of the tree, and then I'm going to do something over here on the left, on the right subtree. And I know I have to go to 90, which means that this entire left subtree is going to be included in it. And here there are 3 odd numbers. So this is going to contribute 3. This one's going to contribute 1. And this side is going to contribute some number. And again, over here, I'm going to get 1 more from this. I'm going to get no more from this because 90 is not an odd number. So 90 is not from Broward, and 93 is already out of the range, right? So I'm going to get 4 from here and 2 from here. So I'll add all of these up in the end, and I'll get the answer 6. Did that make sense? So you're going to go down two paths, one on the left side and one on the right side. On the left side, I'm going to follow 61, 62, and 55 and stop there. On the right side, I'm going to go 61, 85, 93, and 90 and stop there. I won't need to go to any of the other subtrees except to do the counting. Okay. So just by following 2 paths, I can figure out what things I want to add, and I would have the answer for it. So this is for counting the number of Broward County students in the range 55 through 90. Did that make sense, John? Others?
I just had one question. When you
Yeah.
were at 55, you said without exploring any further, you knew that it was
Correct.
within range 55 through 90. How did you know that?
Um, um, no, I take that back. You're right. So you wouldn't know that from here. You have to look at the subtree here, but you will see that the entire range at 55 is 55 through 55, and that's why you could stop there.
Yeah.
Okay.
Okay.
Yeah, that's right.
And then
So
at 76, you know
yeah,
that.
at 76, what will happen is that entire range is 65 through 81, right?
Mhm.
And 65 through 81 is already part of your 55 through 90. And so you can just add that entire score without having to go further down.
Okay.
Okay. Yeah. So that's really what is happening for answering this question. Now, uh, uh, so counting for Broward is what we just discussed. What if we wanted to figure out how many odd number things are there? Well, it turns out that's exactly what we used for, how do we do that? So we want to know whether the number is even or odd. Now, it turns out it won't be useful to store in each node whether that range is even or odd. We're going to need more information, right? So you're better off figuring out how many are in the range 55 through 90 and then checking whether it's even or odd. Okay, because it costs the same, you might as well do the more complicated thing of counting how many are there in a certain range. Is that okay? All right. So that helps us to answer these first 2 questions. Now let's get a little more complicated. What if I want to find the average age of students between IDs A and B? First of all, what do I need to store extra in each node? And then how am I going to get this computation done?
You need to store the ages.
Right?
And then store the sum of all the ages in the subtree.
Very good. So you need both the sum and the number, because otherwise you can't compute the average, right? So we're not going to keep track of the average. Instead, we're going to separately keep track of the sum and the number and compute the average as and when we need them. So what we're going to do is for whatever range we're looking at, we'll figure out when we get to a subtree, if we get to a subtree that we want to add completely, we'll take the entire sum as well as the number of students and pass it on up. So we'll keep track of the sum, we'll keep track of the number, and finally, when we've got that entire number, we'll compute the average. Is that clear? Any other questions? All right. Can you tell me if the product of what so let's assume we have some value stored at each node. We want to know if that product is 0. So every student has some value stored in them. Think of that as, I don't know, number of AP credits that they've had before or something like this. Okay. And we want to know is if I multiply those values, is it 0?
For this, what we would have to do is, if we know if each node has value, then all we have to do is have a Boolean to see if the subtree contains the number 0.
Correct. Good. Yeah. So this is for this example, it turns out to be a Boolean thing where all I need to know is there even a single node in the subtree that has a value 0? Okay. So all I have to do is to keep track of this, and we're done. And in general, we instead of keeping track of whether there is even a single 0 or not, it's probably better to keep track of the number of zeros in the subtree. That's slightly more general, and it'll help you to solve the second part of the problem. Well, actually, you're going to need something else there. There we're asking, find if the product of these values is negative. What if some of the numbers are positive, some are negative, and we want to know if the product is negative?
So I guess there's two ways to do it, where you could multiply it out. Just in case there's something like an overflow
Right.
or
You're
underflow,
right.
you just count how many negatives we've seen.
Yeah, you're absolutely right. So you're probably better off keeping track of both 0 and whether it's positive or negative, right? It's not a Boolean value anymore, or you could keep track of 2 Booleans, one for 0 or not, and if it's not 0, whether it's positive or negative. And then because we are doing a product, we know that multiplying 2 negative values gives you a positive, multiplying a positive and a negative gives you a negative value. So the point I'm trying to make is that the example, the problem looks very cooked up, but the setting, the way we've set things up is very, very versatile. It's very flexible, and you can answer a lot of different questions that have the same flavor, where we're asking between the numbers A and B, tell me this, how many, what about their sum, what about their product, what about their average, what about some part of them, etc., etc. All of these are possible. And in fact, we solved this last time. We could also find if there are repeat values, we can also check if we can also figure out which value has the highest frequency. And the way we did this was actually quite smart. Instead of having separate occurrences of a value, we just kept one copy of the value and stored its frequency. So we added frequency as an extra piece of information and then used that to solve the problem of the highest frequency. So I could also ask for maximum value instead of product of their values. So here, instead of product, I could have said maximum. Remember, this maximum is different from the maximum ID. We have the ID numbers, but this is some other information. So maybe we want to know who has the highest GPA of all the students in this group. Okay, things of that sort. So we could go with the highest GPA, we could go with the lowest age, uh, we could go with frequencies, et cetera, et cetera. So the setting is so versatile that you can answer a lot of these questions that have the same flavor. And the flavor is very simple. It's asking, I have a set of data items that have a primary key value, and I want to do searches based on this primary key value, and I want to ask dynamically how many. I want to do some measure for a specific range. So those are the kinds of problems for which this setting is the best. So once you figure this out, you will see that there are so many problems that fit this general description, and you will be able to solve all of them. That's why I gave you these different questions. Okay. Any any thoughts or ideas on this? So here's another one, which actually was one of the problems from your from your mock competition. This one was about median updates. You remember this problem? Anyone read this? Should we go there? Okay, let's go there. I don't think you're going to be able to see that, right? How do I go there?
Dr. Giri, is that the problem we had last year?
Um, you had it you had it this Saturday.
This Saturday? Oh, no, I was thinking about a median problem you gave us for a mock competition before.
I may have, but this one is a little bit different. So
Oh,
let's see.
goodness.
So the problem here. So how many of you have read this problem, or looked at it, or tried it? No, nobody. Okay, all right. Then this should be fun. Let's take a look. Median updates. Why is it not coming up? Mm. All right, here you go. So everyone knows the definition of median, right? How is median defined?
Yeah,
Anyone?
it's the middle number if it's odd, but
Basically, the
it's
middle number,
yeah.
right? So here it says it gives you what happens if you have an even number of items, then it's not so clear. Here it says it's the average of the middle two numbers. Fine. So either it's the middle number if it's an odd number of items, or it's the average of the middle numbers if it's an even number of items. Now, what this says is that things might get added and deleted, and your job is to keep track of the median at all times. Is the problem clear? Okay. So how are we going to do this? By the way, what is the rank of the median? Anyone know what the anyone know what the definition of rank is?
As an index
It's the index of what?
of where the number sits.
Uh, that's right. So rank is the index in a sorted list, right? So what is the rank of the median?
So the number of items divided by 2, if the list is
That's right.
sorted.
So it's n over 2 roughly. If it's odd, it's exactly n over 2. If it's even, it is the average of the of n over 2 and n over 2 plus 1, right? By the way, if n is odd, then n over 2 is, um, well, actually, it's n over 2, it's n plus 1 over 2, right? Because if n is odd, n plus 1 is an even number, and it's going to be n plus 1 divided by 2. Is that clear? If there are 3 items, it's 3 plus 1 divided by 2. That's the middle guy, right? All right. So since the red-black trees, when they're augmented, it allows us to do rank and select. Essentially, we can do this median quite efficiently by figuring out what item sits in the middle location anytime we want. Okay, that's one way of doing it. Is that clear? Uh, so once again, if I build a red-black tree, and if I store the size information in each node, I can do the rank query anytime I want. So rank query says, sorry, select query. Select query says, I give you a rank, I give you the number 7, and you have to tell me what is the 7th smallest item in the list. Meaning, if I were to sort it, what will sit in index number 7, right? So that's called a select query. Now here, you're asking, what we need to do is to answer median queries, meaning give me the median value whenever I ask you, okay? Now I know items are being added and removed and so on, so the list keeps changing. The median keeps changing. And the question is, how do I keep track of it? Well, one way to do this is to build a red-black tree and to always ask for n over 2, uh, the item with rank n over 2. So that's a select operation with k equals n over 2. And that should work just fine. However, that operation is going to take how much time?
Is it login?
It is log n. That's right. Now, question is, can you do better?
So like maybe we can hash the values, but I don't see.
Put hashing out of your head.
Okay.
That's not something we will discuss here. That's a good practical solution, but again, even practice doesn't help you here, because figuring out the rank of something that's in a hash table is crazy. Okay, so don't think about hashing. It's not going to be useful for you for designing efficient, uh, 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 worst case efficient algorithms. It's great in some cases, but even that even that won't help you here.
Okay.
Because I just don't know. I'm constantly throwing in things and removing things, and I'm asking you what's the middle item. Hashing cannot help you there, right?
Right.
So, so don't go to hashing as your first solution. Try other things first. If everything else fails, you can think about hashing. Okay,
Okay.
that would be my advice for you. Uh, Hashing is good to speed things up where you already know what you have to do. It won't help you in settings like this. So let's go back to red-black trees, because we're talking about red-black trees until we are blue in the face. So let's think about red-black trees here. And the question is, do I really need a red-black tree here, or can I do something simpler, right? What do you think?
And I'm going to say, since this is dynamic, uh, we should use a red black tree.
Very good. Yes, that's the right answer. Remember here, the problem says you might need to add something, remove something, or you might ask for the median. Okay, those are the 3 operations you have. So because it's a dynamic data set, you are going to need a red-black tree. Otherwise, your insert and delete becomes very, very slow. Okay, good. So now we know we want to use a red-black tree. So the next question is, uh, how quickly can I find the median? do I still need log n by doing this rank operation and select operation, or can I do something better? So here we're going to, since I'm almost out of time, let me try and speed this discussion up. Let's take a look at this red black tree here. Can you see this?
Yeah.
Yes.
Okay, good. Um, so let me close these things here so that we can have a good discussion. Yeah. So um, if I want to find the median in a tree with just your, so let's actually use this tree here with all the size information. I know that I can do this because as long as I keep track of the fact that there are 13 nodes in the tree, I know that the middle item is of rank 13 plus 1 divided by 2, which is
7.
7.
Yeah.
So, so we know it's the 7th item we want, and so all we have to do is to do select operation on number 7 with this tree. And the way we do that is we know there are 4 items in this subtree, so this guy has rank 5. So therefore, we are looking for the 7th item, which means we have to go to the right. So then we start the search here. This time we are going to search for 7 minus 5 because this guy has rank 5. And in this subtree, we want the second smallest item, right? So the second smallest item in this subtree, since the left subtree has 4, it's all going to be here. So we want the second smallest item in this subtree. And then we come down here and we want the second smallest item in this subtree. And since the left subtree has 1, this is the answer. So the 7th smallest item is 71. So that's your median. Now the question is, as I insert things and delete things, the median keeps shifting around. So what do I do? Should I keep going and doing this select operation every time, or is there something smarter I can do? So first of all, how many of you believe that we can do something faster? Okay. I see at least one hand. Are there others who think we can do something faster?
I believe there's some information that we can add to the notes that will help us, but I cannot figure out right now like what
So,
it could be.
but what is your intuition? Why do you think it's possible to do faster?
Mm, well, I don't know.
All right. So
Okay.
one thing we know is that is that the uh, the median moves by just a little bit. So instead of rank 7, the next time around, either it'll go to 6 or 8 or the average of one of the neighbors, right? So if we can keep track of those neighbors, then life would be great. So one thing we could do here is to add some extra information that says, tell me which one comes after 71. So each guy has a pointer to the next item and maybe also to the previous item. So everything here is linked. From 16, you have a link to 20. From 20, you have a link to 52, 52 to 55, 55 to 61, 61 to 65, 65 to 71, and so on and so forth. So we can simply do a in-order traversal and link them all up. Okay. Now, if something gets inserted, we have to make sure those pointers have to be properly fixed. Sure, that's fine. Same thing if we either insert or delete, we may have to fix those pointers. So we can keep track of this. Now it becomes easy because uh, at this point the current median is 71. If I insert an item, doesn't matter where I insert it, even if I insert it here, what's going to happen is, either I insert it to the left of it or to the right of it. Either way, 71 needs to be averaged with something that comes before it or something that comes after it. And as long as there's a pointer to go to the previous or the next item, we can figure this out. Is that clear? So what I'm going to do is I'm going to have a separate data structure here that says, hey, the 71 is my current median, and this is where it sits. So from that median item that will be stored elsewhere in a separate variable, I will go directly to the median. And then I have pointers to the previous and the next item. And every time I insert or delete, I will figure out whether it has to move to the right or to the left. And I will fix that appropriately. Is that clear? So I can actually figure out the median in this dynamic tree very efficiently simply by adding some extra information. Okay, so these are all examples of what you can do with your data structure, but they all require you to know how to build a red-black tree. And it looks like not everyone has figured out how to implement them. So it's a good idea for you to get that working. If you have questions, I'm happy to work with you after the class to debug your at least point you in the right direction. I may not be able to debug your programs completely, but I can definitely help.
Thank you, Professor.
All right. So good luck this Saturday. And the others have not asked any questions. Are you still there? Are you alive? Clement, Azar, Adriana?
Oh, I'm alive. I'm alive.
I am.
Just checking, just checking.
Yeah.
All right. So all of you are signed up for this Saturday, right? At least the ones here. All 8 of you.
Yeah.
And Ricky
Yeah.
was here earlier, so he also I know is. And there are 3 others that are missing in action today. Make sure that they know about the Saturday thing. Keep reminding them, keep bugging them about and remind them about Saturday. Make sure they don't bail out at the last minute. Okay. And
For sure.
I will be on Discord as well, and I will try and send you my Discord information. They may have put me on a different handle there, so I'll send you that information. So feel free to contact me, and we'll be in touch. Cool.
Good.
Cool.
Thank you.
All right.
Cool.
So we'll talk next Thursday. I see some chat here.